A short introduction to numerical series. Let's start watching this short video.
60-second adventures in thought. Number 1. Achilles and the tortoise. How could a humble tortoise beat the legendary Greek hero Achilles in a race? The Greek philosopher Zeno liked a challenge and came up with this paradox. First, the tortoise is given a slight head start. Anyone fancying a flutter would still rush to put their money on Achilles, but Zeno pointed out that, to overtake him, Achilles would first have to cover the distance to the point where the tortoise began. In that time, the tortoise would have moved, so Achilles would have to cover that distance, giving the tortoise time to amble forwards a bit more. Logically, this would carry on forever. However small the gap between them, the tortoise would still be able to move forwards while Achilles was catching up, meaning that Achilles could never overtake. Taken to an extreme, this bizarre paradox suggests that all movement is impossible. But it did lead to the realization that something finite can be divided an infinite number of times. This concept of an infinite series is used in finance to work out mortgage payments, which is why they take an infinite amount of time to pay off.
In the video, two different numerical series are mentioned. The first is 1/10 plus 1/100th plus 1/1000th plus 1/10,000th, etc. Let's analyze a number which you have certainly met before now. 1/9. This number can be rewritten as 1/10 plus 1/100th, etc. Therefore, we can infer that the sum of the endless terms which have this shape, 1/10 to n, with n, the exponent, starting from 1 and varying among all the natural numbers, gives the fraction 1/9. As a result, a faster way to write the sum is using the summation sign. Now, let's focus on the second series. Starting from a square which has the side equal to 1, let's divide it in two parts. Now, we choose the left upper part. Let's divide in two equal parts the other half and choose that which is on the right. And let's repeat this procedure. And again. Going on, we obtain the following result, which can be rewritten like a symmetry. The sum is a symmetry equal to 1, the surface of the square which was at the beginning. But obviously, not all the sums of endless terms give a finite sum. In fact, for example, the symmetry of n doesn't give any finite result and it is called positively divergent. Or, it is possible to write series which are indeterminate, such as the symmetry of -1 to n.